Alright, we've got a right triangle ABC, forcing me to think about the big triangle there. Measured angle ABC equals 90 degrees. That's vertex B, nicely labeled already. And BD is perpendicular, which means that it makes 90-degree angles to ADC. The letter that's shared in both of them is where those 90-degree angles are. Even without all that, you should be recognizing this diagram as altitude rule or leg rule, or just a triangle similarity problem. So we got to take the information that we're given. AD equals 3, CD equals 12, and very important that you use a variable. The length of AB is x, because this is really how we're deciding what we're doing. This is the leg rule, so I'm just going to start out with the shortcut. Leg rule says that the leg is the shared piece between the two triangles and always goes there in the proportion. And the other two parts are the part of the hypotenuse close to it and the whole hypotenuse. So if you've got that rule memorized pretty quick, the leg is x and the part is 3 and the whole thing is 15. You cross multiply and x times x gives you x squared. 3 times 15 is 45, and then we are simplifying, well, we're taking the square root and simplifying this radical. We get x is the square root of 45. 45 can be rewritten as 9 times 5, and the square root of 9 is 3, and we get 3 root 5. And the nice thing about the multiple choice, even if you don't know how to simplify the radical, you can just plug this in the calculator and plug these two in the calculator, and this one will give you the same value because simplifying is just rewriting the number in a different form. If that's good enough for you, feel free to stop watching, but the big idea of this problem is that there are 3 similar triangles, and what the altitude rule and the leg rule are doing is just a shortcut for setting up the proportion that is most commonly given to you here. So in this small triangle we've got the x and the 3. The medium-sized triangle we've got the 12 and nothing else. And in the big triangle we've got the x over here and the 3 and the 12 added together. So the leg rule is always going to be a shortcut for finding a proportional relationship between one of the 2 smaller triangles and the big triangle, and that's why you have to add these pieces together to use the whole hypotenuse. This is the hypotenuse in this one, hypotenuse in this one, and a little bit hard to see because there's 2 x's, but this is just setting up all the corresponding parts in those 2 triangles.